Hi, welcome back to this last session on this part of the course. So far, we've currently got two LEDs that are flashing on and off based on a time interval. We've talked about using macros to help us define code so we don't have to keep repeating ourselves. We've started talking about variables, and we've written our very first, very basic function. If we look at our code, you can see these things here in the code. Here are our macros at the top for our definitions. We've defined a global variable. We've got our setup function, our loop function, and the function that we wrote ourselves, which actually has got in it a local variable. But at the moment, there's no conditional logic happening. There's no actual logic. It's just whatever we tell it to do here. So what we're going to do is we're going to see if we can rewrite this slightly to give us a bit more power. We're going to try and work into it some if conditions. So I'm just going to bring up another board here just to show you. In Arduino, we have a conditional called if. It goes purple. The condition we're going to check goes in curved brackets or parentheses. And then if whatever's in those brackets evaluates, comes out to be true, it will run whatever follows between the curly brackets. But it will only run that code if what's in the thing is true. So if fruit equals apple, and you'll notice that we have to use double equals, then if we pass in the word apple, and that would have to be a character, then something can happen in here. It could be we want to digital write, I don't know, pin 2 as high. So we've somehow written some code that detects if we send in the word apple, this function, that it will send pin 2 high. Now we can actually expand on that. We can get it to do this, but we can also get it, if we add the word else, another set of brackets, we can get it to do something else if the condition in the first option is not true. So we could say get it to write pin 3 as high. So if what we send in is the word apple, do this. Else, if this is anything else other than apple, do this. And that gives us some directional logic. We can do option 1 if this is true, option 2 if this is false. So let's build this back into our original sketch so that we can pass in the letters G or R, and in doing so we can actually then turn our red LED on or our green LED on. So now we're back in our normal sketch. Let's change this bool to a character, and let's call the character color, because we're going to pass in a parameter or a variable called color. So if round brackets color equals two equal signs, because we're actually checking whether it's the same. Normally one equal sign up here allows us to set the value of our variable. Two equal signs allows us to check the value of a variable. That takes a bit of getting used to. You'll get there eventually. If color is red, now we can't just type R because it thinks that's a variable. It thinks it's a parameter. I won't know what to do with it. But if we put that in quotation marks, and it doesn't matter whether we use single quotation marks or double quotation marks, it will check that the value of colour is the same as the letter R. Then we want it to do this. So we go, open our brackets. I'm going to copy these 2 lines because I know they work. Paste them in here. Now, you don't have to, but traditionally we use tabs to set things in, and you'll notice that the software is putting these vertical lines to help you line up your conditions and your functions with their closing curly brackets. It helps, it's called nesting, and it helps with making your text clear. So if we set the color to be red, then we want the red LED to be high and the green LED to be low. Else, well, if we don't set red, send any other letter, we want the green LED to be on the set at low, high. And then we will finally want it to wait whatever happens. So because we want it to happen either way, we put it outside the if, and notice how it's lined up with that left-hand edge. So it will now go, when we call set LED, it will check, have we sent a character called color? If not, if that character is red, it will do these 2 lines of code, set the red LED to high, the green LED to low. If it's anything else, it'll set the red to low, the green to high. If we hit verify, that has done compiling. Now what we need to do is we need to go back to our loop and we need to set this. So let's set it to red, and we'll need to make sure that that's a string. What you can actually do in this software, if you realize that you've typed the letter, say G for green, and you've forgotten to put the quotation marks around it, you can click in before and press the quotation marks like that. Or you can highlight the string like that and then press the quotation marks. If you were in a word processor, that would overwrite the letter G. But because you're in a computer programming environment, it's so used to people forgetting to put quotation marks that if you highlight it and press the quotation mark key, it puts 1 quotation mark before and 1 afterwards. It's a nice little shortcut that saves time. And let's just, for giggles, let's set LED, and let's say B for both. I wonder what it will do if we do that. So we're going to call, zooming out a bit, this whole function, this whole program. It's going to call set LED red. Hopefully it should set the red LED there to high. Then we're going to call green. Well, hopefully that will set our green LED to high. Then we're going to call B. And then we'll see what happens. So let's verify it. Done compiling. Upload it. And let's go have a look at the actual hardware. So here's the hardware. We're getting red on, and then the green on, and then we're not getting a both on. To me, it looks like the green is staying on longer. Almost looks to me like the green is staying on twice as long. Why do you think that would be? Well, it's of course because we've done something weird in our code. So let's go back to our code and have a look at this function down here. What we've done up here is all good. It's all to do with this set LED function. So I'm going to zoom in on that just so you can see the set LED function. We've got a condition if color is R, and then we do this if it's anything else. But that's not quite what we want, is it? We actually want to check if the color is green, and only do this if it's green. Well, the good thing is, we've got if, we've got else, and we can actually also have else if. Else if. Each language does this slightly differently, so sometimes it feels wrong, but in this case it's else space if. Curly brackets, color equals green. And now we need to tell it what to do if it's none of the above. What do we want it to do if it's nothing? Well, we can either have it, let's copy those, paste them in. If it's not red and it's not green, sorry, if it's not red or it's not green, let's make everything go off. That's a nice safe default. So if it's neither red nor green, then just switch off. So we now got a third condition. Let's press verify. No problems with that. And upload. Let's go have a look at it. So we've got red, green, off, red, green, off, red, green, off. I'm going to make the timing a little bit longer so you can see it. Red, green, off, red, green, off. Here's a challenge for you. If you think you understand how this function now works, modify it to add a third value, not R, not green, any other letter that you want, that allows you to switch on both codes, both LEDs at the same time, and then build that into here. So maybe you could use B for both. You could use O for on, for all on. You could use E for everything. Use any letters you want, just pick something. Try to add another condition to this loop that allows you to set both LEDs to on. That's the condition, that's the challenge I'm setting you. I'll put the answer, or an answer, there are more than one way of doing, there's more than one way of doing this, in the notes on the next page, but have a go yourself first. You can't break it. Until next time, see you later.